Welcome back you students to this class of mathematics, and in my previous class we have already discussed all the basic concepts of a mathematics, and we have discussed the transpose of a matrix, symmetric and skew symmetric matrix. Based on that we have exercise 3.3. So first I am discussing question number 3 of this exercise. In this question you are given a transpose of a matrix A, which is 3 4 minus 1 2 0 1, which is a 3 by 2 matrix. You are given a matrix B, which is a 2 by 3 matrix. You have to verify these two parts, that A plus B transpose is equal to A transpose plus B transpose. You also have to verify this part, that A minus B whole transpose is equal to A transpose minus B transpose. So to verify all this, I should have A transpose, B transpose. It is given, A transpose is given. So how can I find A by A transpose? So I know the property that A transpose is A. So if I take the transpose of A transpose, I get matrix A. So how do I take the transpose of a matrix A transpose? I write its rows as columns. So A transpose becomes A. 3 4, first row becomes first column, second row becomes second column, third row becomes third column. A transpose is a 3 by 2 matrix. It has got 3 rows, it has got 2 columns, 3 by 2 matrix. So A will be a 2 by 3 matrix. It will have 2 rows and it will have 3 columns. Now similarly, I am given matrix B, which is a 2 by 3 matrix, and I find out matrix B transpose, which is a 3 by 2 matrix. So left hand side is A minus B whole transpose. So from A, I have to subtract matrix B. 3 minus 1 0 4 2 1, this is matrix A, and matrix B is minus 1 2 1 1 2 3, and I subtract these two matrices, and whatever I get I have to take its transpose. So subtraction of two matrices is element wise. 3 minus minus 1, 3 plus 1 is 4, minus 1 minus 2 is minus 3, 0 minus 1 is minus 1, 4 minus 1 is 3, 2 minus 2 is 0, and 1 minus 3 is minus 2. Now I have to take its transpose. This is a 2 by 3 matrix. I take its transpose and I get a 3 by 2 matrix, that is 4 minus 3 minus 1 3 0 minus 2, and this comes out to be a 3 by 2 matrix. Now I calculate its RHS. Now we calculate the RHS. Right hand side says we have to calculate A transpose minus B transpose. So I have written the values of A transpose and B transpose. I subtract them. So I get 3 plus 1 4, 4 minus 1 3, minus 1 minus 2 is minus 3, this is 0, this is minus 1, and this is minus 2, and this is a 3 by 2 matrix. So now students, we can see that the left hand side was also this. So I get that left hand side and right hand side have become equal. Now we are doing question number 5, part 1. You are given a matrix A. You can see it is a column matrix and it is a 3 by 1 matrix. You are also given a matrix B, which is a row matrix, and it is a 1 by 1 cross 3 matrix. Now you have to verify that AB whole transpose is equal to B transpose A transpose, which is the property of the transpose of a matrix. So we first calculate the left hand side, which says you have to calculate AB whole transpose. So that means I multiply the two matrices A 1 minus 4 3 with the matrix B minus 1 2 1 3 cross 1 1 cross 3, and whatever I get I have to take its transpose. Now by looking at these two matrices, I can see that the order of the resulting matrix is going to be 3 by 3, and I have to take its transpose. So 1 into minus 1, 1 into 2, 1 into 1, then minus 4 into minus 1, minus 4 into 2, which is minus 8, and minus 4 into 1 is minus 4, then 3 into minus 1, 3 into 2, and 3 into 1. So we take the transpose of this matrix and we get minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6, 3, which is also a 3 by 3 matrix. So I got the value of LHS. Now we are calculating the right hand side is B transpose into A transpose. So I see that the matrix B, which is minus 1 to 1 row matrix, its transpose is this. Matrix A, its transpose is this. So I multiply these two matrices and the result is again going to be a 3 by 3 matrix. So minus 1 multiplied with these three elements to get the first row. So I get minus 1 plus 4 minus 3. 2 is to be multiplied with these three elements to get the second row. That gives me 2 minus 8 and 6, and 1 to be multiplied with these elements to get the third row, and hence I get the value of B transpose A transpose. So now I observe that the LHS also had the same value, and hence LHS and RHS become same. So I have verified the property that AB transpose is equal to B transpose A transpose. Now question 6 part 1. You are given a matrix A cos alpha sin alpha minus sin alpha cos alpha, and you have to verify that A transpose A is equal to identity matrix. So I take the transpose of A. I calculate LHS, take the transpose of this matrix, multiply it with matrix A. So I use the rules of multiplication of a matrix. First row with first column, cos alpha cos square alpha minus sin square alpha. So minus minus plus sin square alpha. First row with second column, I get cos alpha sin alpha minus sin alpha cos alpha. Second row with first column, sin alpha cos alpha minus cos alpha sin alpha, and for this I multiply second row with second column. So sin alpha into sin alpha, which is sin square alpha, plus cos alpha into cos alpha, which is equal to cos square alpha. So this is the identity, trigonometric identity. This element is 1, this element is 1, these two elements are 0. So I get the identity on the right hand side. Question number 10, exercise 3.3. Question 10 says that express this matrix as the sum of a square, sum of a symmetric and a skew symmetric matrix. So we use the theorem 1. Theorem 1 says that A plus A dash is symmetric and A minus A dash is skew symmetric. So I have to see, now I have to make use of theorem 2. Theorem 2 says that every square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. That is, A can be expressed as A plus A transpose upon 2, A minus A transpose upon 2. Theorem 1 says that this matrix is symmetric. Theorem 1 says that this is skew symmetric. So that means if I am able to express A as the sum of these two matrices, so one of them will be symmetric and the other will be skew symmetric, and you can verify that A by 2 comes out to be A, and A dash by 2 minus A dash by 2 will cancel. So LHS and RHS are equal. So how to express this matrix A? For that I first calculate A plus A transpose. So what is A? A is given to you 3, 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 and 2. Now what is A transpose? Means its transpose of this matrix only. So I read a row and write it in a column, which comes out to be 3, 3 minus 1 minus 2 1 minus 4 minus 5 2. So now I add up these two matrices. So what do I get? 3 plus 3 is 6, 3 minus 2 is 1 minus 4 is minus 5, minus 2 plus 3 is 1, minus 2 is minus 4, 1 minus 5 is minus 4, minus 4 minus 1 is minus 5, minus 5 plus 1 is minus 4, and 2 plus 2 is 4. So now if I calculate A plus A transpose upon 2, that means I divide every element of this matrix by 2, because this matrix is nothing but A plus A transpose. So I divide every element of it by 2. So that gives me 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, and then minus 5 by 2, minus 2 and 2. So then I have to check that this matrix is, this A plus A dash by 2 is symmetric. This I have to check. So I will find out, let me call this matrix as B. So I have to check that B is symmetric. For that I have to calculate B transpose. So I calculate its transpose, which comes out to be 3 1 by 2 minus 5 by 2. So I am reading a row and writing in a column. Similarly 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2 minus 2. So I have taken the transpose of this matrix, but what I get is that these two matrices are same. So I check that B transpose is B. That means A plus A transpose upon 2 transpose is A plus A transpose by 2. That means the matrix A plus A transpose by 2 is a symmetric matrix. Now we calculate A minus A transpose upon 2. So I divide the result by 2. This is matrix A and this is its transpose. Now I calculate and I get 3 minus 3 is 0. 3 minus minus 2, 3 plus 2 is 5. Minus 1 plus 4 is 3. Minus 2 minus 3 is minus 5. Minus 2 plus 2 is 0. 1 plus 5 is 6, minus 4 plus 1 is minus 3, minus 5 minus 1 is minus 6, and 2 minus 2 comes out to be 0. And if I divide this matrix by 2, that means I have to divide every element of it by 2, 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3 and 0. So I get this matrix. So now let me call this matrix as C, and if I calculate the transpose of C, I have to check that this matrix, which is A minus A dash by 2, I have to check that this is skew symmetric. So if I call this matrix as C, so I have to check that C dash should be equal to minus C. So I calculate C dash. So C dash means I take its transpose. I read a row and write it in a column. So 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3. Then minus 3 by 2, minus 3, 0. And what I observe is this is nothing but negative of matrix C. So if I take negative common from this matrix, what do I get? 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 0, 3, minus 3 by 2, 3, 0. So which is negative of C, and hence I observe that C dash is equal to minus C. So C is a skew symmetric matrix. But what was C? C was nothing but A minus A transpose by 2. So A minus A transpose by 2 it is a skew symmetric matrix. Now I have to check that A is equal to A plus A dash by 2, A minus A dash by 2. I have already calculated A plus A dash by 2 and I have called it B. I have already calculated A minus A dash by 2 and I have called it C. So I substitute the values of B and C. Substituting B and C, so B and C, I have to calculate B plus C. So if I add these two matrices, 3 plus 0, 1 by 2 plus 5 by 2, 6 by 2 is 3. I got this is equal to A. So I have expressed A as the sum of a symmetric and a skew symmetric matrix. Question 11. You are given two matrices A and B which are symmetric and their orders are also same, and you have to check that AB minus BA is symmetric or skew symmetric. We take AB minus BA transpose, and this is equal to AB transpose minus BA transpose, which AB whole transpose is equal to B transpose A transpose, and BA whole transpose is A transpose B transpose, by using this property of transpose of a matrix, that AB transpose is B transpose A transpose. We have used this property. Now We already know it is given to us in the question that A and B are symmetric matrices. That means A transpose is A, B transpose is B. So replacing A transpose and B transpose by A and B. So B transpose B, A transpose A. And here also, now I take negative common, so it becomes AB minus BA. So I got that AB minus BA whole transpose is equal to negative of AB minus BA. That means AB minus BA is a skew symmetric matrix.